So hi everyone, I'm a contributor to the OpenStack Glance project. My name is Sabri and I'm also part of Glance core team. In my other life, I work as a senior software engineer at VMware, where I work on VMware's distribution of OpenStack called VMware Integrated OpenStack. It's nice to virtually meet you all, and I really envy all of you guys in New York City. I did my master's at Columbia University, not too far from there. So let's jump on to today's presentation. Yeah, I hope everyone can see this. So generally, when someone thinks of Glance, they associate it with like uploading or downloading images. And but there are like many cool features in Glance than that meets the eye. Today's presentation is going to be about those features in Glance that are like beyond image upload. So first things first, it's always good to start with the mission statement of Glance project. So okay, you might be wondering what is the official logo. It's kind of resembles a gramophone, which is funny. And so the original mission statement of Glance was to like provide services to upload, browse, share, and distribute and manage bootable disk images. So this original statement came about because Glance was specifically created to cater to Nova because it was originally part of Nova at some point of time. And then there was like a shift in the focus from disk images to generic data objects, also known as artifacts, and that can be consumed by many OpenStack services like templates for Heat or application packages for Murano. I think you guys might have seen a presentation earlier from Mike. He would have presented about the Glance artifact repository. So this shift in focus was like a new identity for Glance from an image store to an image catalog service. So this happened somewhere around 2014. If Brian is right, I kind of took this from his slides, and I think somewhere around June of 2014, the shift in this focus was born. And as you know, the Glance API at its current form has like three versions. So the first version is the V1 API, which has been since the day one of Glance. And the current one is the V2 API, which has been updated quite frequently in the past 2 years. And we have some new APIs that came into V2, like the tasks and the metadata definitions. We'll talk about all these things later in the slides. And there was this GLAR API, also the short for Glance Artifacts Repository. It was actually originally planned as a V3 API, but was spun out as a separate endpoint, and that brings in the artifacts. I think it's always necessary to kind of take a look at the architecture of a project before we go much deep into the features. It's always a good starting point, and I'll just quickly run through the architecture of Glance. So the V1 architecture is like pretty simple. It has two services, the Glance API and the Glance registry. The Glance registry is a service that is used to interact with the database, and the Glance API is like the front end facing the users, which provides all the Glance APIs. And these two services communicate over a message channel, and the Glance API has different drivers for different storage backends. So these storage backends are the ones that actually store the data bits. And we will talk about the Glance stores later. And then came along the Glance V2 API, which was like much more thought through in design and kind of made the Glance registry services optional. The general design of the Glance V2 followed something known as the domain model. If you've taken a class on what do you call the design pattern sometime, then you would have definitely come across a coffee making exercise which uses the decorator patterns. So the implementation of Glance V2 was done specially emphasizing on the single responsibility principle. You can think that as like a way of enhancing the behavior of an object by like what do you say, statically or dynamically wrapping different layers of functionalities around it, like you see in an onion. So the different layers that I'm talking about are the notifications, the authorization, the policies, the coda, and all this, which are on the slide. And we also made one more architectural change, that we moved the Glance store, which was essentially part of the Glance API, into a separate library. It's still part of the Glance API service, but it's just being, in order to maintain it more appropriately, we moved the Glance stores along with all the drivers into a separate library. Yeah, so that's about Glance v2. And then came along the Glance artifacts repository, also known as CLAR. So this kind of follows the same design architecture as the Glance v2 API, but it just brings in the additional plugins for different artifacts. So some like the plugins for heat templates or Mistral workbooks, etc. So this pretty much was very similar to v2. So this was a quick probably 2 minutes rundown of the architecture of Glance, which was important for the later on features that we'll be talking about. And the other thing that we need to take a look at is the look at how a virtual disk is represented in Glance. So if you take a virtual disk, it's basically it can be represented by two properties: the disk format and the container format. These are the bare minimal properties required to represent a specific image. So the disk format is nothing but the type of the underlying virtual disk. So the virtual disk comes in different formats specific to different open source or commercially available hypervisors. So you have formats like QCOW, you have formats like VMDK, raw formats, VHDs for different hypervisors. And you have something known as a container format, which is nothing but it's basically an archive that has the virtual disk along with some additional metadata. One of the popular container format is OVA, which stands for Open Virtualization Archive, and it has some files like the OVF, which is basically an XML file with a description of the virtual disk. So why do we need an OVF? So it's basically like if you have a virtual disk, it contains all the data about the guest operating system, but there is a lot of things that that somebody needs to know when they have a virtual disk. For example, what type of guest operating system does this specific disk have, and what kind of hardware configuration that it needs, and what kind of memory requirements or resource constraints that is needed by this virtual disk. So all this data is usually not present in one of the underlying disk formats, and that's why we use container formats, which has more enhanced information. So that's about the basic properties of an image. There are some other image attributes, like we have a virtual size, which is nothing but the actual size of a virtual disk of a sparse disk. So there are the different virtual disk formats have something known as a sparse disk, which is like kind of what do you say? It's basically a disk which only takes up the space that is required on the file system, but presents a whole different space to the guest operating system. And then you have some of the privacy features of an image, which is controlled by the visibility attribute. And you have checksum, which is basically MD5 hash of the image data to maintain the integrity of the data. And there is some other properties that mention the minimum RAM and the minimum disk that is required to run that specific image. So why did we take a look at the image properties? We'll come back to that in a little bit. So there are also something known as the custom properties of an image. Like you can associate any random key value pairs with an image. So this is useful for mostly for the consumers of the image. In most sense, from the OpenStack services point of view, this could be Nova and its drivers, but it can also have some additional information for the end users. Like I could associate some key value pairs to denote what specific image I have. Like for example, if I have a Windows image, I want to know what service pack that has been installed on this image. So these kind of things you could associate it with random key value pairs on the image. And then there are other properties that can be, these random properties can also be used by services specifically like Nova. For example, if you have a property like a WIF model, this specifies the type of the virtual NIC that is honored by most hypervisors. And if you have something like a CPU policy, then that defines how the specific virtual machine instance should be pinned to a specific CPU, or should it be a shared policy. So, and there can also be other properties for quotas and resource reservations. This is mostly used in the case of NFV appliances. So as you can see, there are like, okay, there's one more thing. There's like custom tags. Like if you have an image, then you could associate with a custom tag, which is which can be used to like search that specific image later on. Like if you do a glance image list, hyphen tag, and then specify that the tag name, then those images that are matching the tag will be listed. So if you see here, there's a whole explosion of metadata, right? I mean, we talked about the basic attributes in Glance, and then we spoke about the custom properties in Glance, which are honored by the Nova services. And there are some properties for NFVs and some custom properties. So there are like so much of metadata that's been available across the OpenStack ecosystem. So metadata definitions is a common API that helps to like organize this whole set of metadata by resource types. So it not only constrains itself to images, but it also defines the resource types for, say, flavors or Cinder volumes, etc. This was introduced in the V2 API, and one of the most consumers of this API is Horizon. So if you go to Horizon, you could see like a wizard which kind of reads from this API and populates a table which organizes the whole set of image metadata into namespaces. So into namespaces and properties. This is very useful when you are getting into OpenStack and get overwhelmed by the number of metadata properties that are available. Because each of the service implementation, for example, Nova, could use like hundreds of tens and hundreds of image metadata, but it's really tough to get this information out because it's deep buried into its implementation. So this was the use of metadata definitions. This is like a sample metadata definition JSON, which is used to which you could create in Glance. Which specifies how a specific property is associated with a specific namespace and what kind of resource types can it associate with. For example, can it be with a Glance image or a Nova flavor, etc. Okay, so let's switch the gears, and I've opened up the image state transitions of a Glance image. So before we look into some of the other features which are beyond image upload, it's really critical to understand the life cycle of an image. So the life cycle of an image, as most of like most of the users of OpenStack would be aware of, is like three of them. When you create an image, the image begins in a queued state, which is like the first state where no image data is associated with the image. And as you like start uploading image bits to the image, it moves from the queued to the saving state. And when the upload is successful, it becomes an active state. And if for some reason it gets failed, it gets killed in the V1 version of Glance API. But in the V2 version of Glance API, it goes back to the queued state. So these are the three states that it's absolutely critical for everybody who works with Glance images to know about. But there are a bunch of other state transitions that we might concentrate today, apart from the usual ones. So these are the pending deletes, the deactivation states, etc. So I'll come back to this image state transitions once in a while when I discuss those specific features. So the next thing to talk about is about the image protections. So some of the features, we have a feature in Glance called deactivate an image, which is basically to restrict image uploads or downloads to a specific image. For example, if you want to like blacklist an image in your cloud temporarily for some use cases, then you could use this deactivation API. So that would move an active image to the deactivated state. And then you could, once you are comfortable with reactivating that specific image, you could do that by issuing the activate API call. The other thing to note is that the image data in Glance is immutable, which is one of the principles that around which Glance revolves, is that the image data is completely immutable. And a checksum is usually associated with the image once the data is uploaded in order to maintain this integrity. There is an attribute called protected in Glance. This is used to make an image read only. For example, if some certain images are like really critical, an admin could mark that specific image as protected so that he could avoid accidentally deleting the images. So you could remove this protected flag and then the image could be deleted safely. So these are some of the features for image protection. There is also something known as property protections. Like there might be, I talked about some of the NFV use cases where you could associate resource reservation properties with an image. Like if I want a specific bandwidth on my network card, so I could associate a metadata for that with an image. But what happens if these properties of an image are misused? Like you don't want every tenant to manipulate the resource reservation metadata, right? So in this case, Glance allows something known as property protections. Using the policy JSON file, what you could do is like you could specify some properties that are protected from being updated. So even an owner of an image cannot like update the property, those specific properties, and it allows for more security of the image. So we looked at some of the security features in Glance. The next one is that Glance also has a soft delete feature for images, which is like if you're in like a high churn environment, right? It may be really costly to scrub the data, image and its data. So, if you have like tens and thousands of users of your cloud and everybody goes about like deleting their set of images, then it's really critical that we handle them consistently. So Glance has an option of delayed delete if it's set to true. The image state transitions happen from an active state to a pending delete state. So the pending delete state is nothing but it's marked for deletion, but the image is not deleted. In order to clear this image, in order to purge all the image and its data, Glance has a utility called Glance Scrubber, which is used to basically scrub the image data. So you could tune the scrubber with some scrub time and a pool size to specify when you want to invoke this action and how much of a load should it handle. And the main task of the scrubber utility is to perform like move the pending delete state into the deleted state after clearing the image. So after this, I want to talk about the image sharing aspects in Glance. Image could be shared with with everyone in your cloud or with like specific tenants or users. So so this is like the the privacy features of an image, our own privacy version. In V1, in order to make an image public, there was an attribute called as public, which you could use to manipulate its privacy settings. You could basically share with a specific tenant, and you also could allow them to share further. So if it has an attribute called can share, which when set to true, the person whom you have shared this image could further share. It's like the Facebook post. But in V2, we kind of changed this behavior, like a tenant could not like share the image further, and they have to have something like they need to like accept or reject a shared image before they start using it. So this is some more additional information about sharing of images in Glance. And next is like I want to talk about like Glance cache middleware. Like Glance has this like if you're using Glance API, you could enable local caching of Glance images. That is, you could enable add a WSGI middleware to your paste pipeline, and then you could make images you could cache the images locally on the node on which the Glance API is running. So why do we do this? We can do this to increase the scalability and overhead when fetching from a backend. For example, if you're using an object store, you need to basically fetch this image over and over the network, and this, of course, will have some overhead. And if an image is like constantly being used, for example, if you release a new image today to your cloud, which is being used by all the tenants of your cloud, then you could, if you have enabled caching, the same file is being served by different Glance API services on that specific node, and will improve the efficiency of downloading the image for the user. With As I already said, it's a WSGI middleware, and it brings in a bunch of new APIs for effective cache management. Like if you know that you're releasing a new image today to your cloud, then you could like prefetch this image on all the Glance API nodes. You could basically work out your own algorithm to on how to cache which specific image on specific nodes, and then you could query and manage, and you could do a whole bunch of operations around this. It's very useful in a public cloud scenario. Okay. So before we go into the next set of features, I wanted to talk a little bit about the Glance stores. I briefly mentioned in my slide before that somewhere in a few cycles back, we split this Glance store and moved it into a separate library. This is basically the backend that stores the image data. So Glance API interacts with this library to pass on the image data, and it's the responsibility of the Glance store to store the data onto specific backends to which it is configured. It's kind of conceptually analogous to the hypervisor drivers in Nova. We have like many drivers in Glance store today. We have the file system driver, which is used to, if you want to use if you don't have any external storage backend for Glance, you could use the same node on which Glance API is running and use its file system as a local storage. And you could have, if you have hosted your image externally on a file server, on a web server, then you could provide the URL of that specific image. For that, we have the HTTP store, and we have the Swift store for the object store, and RBD store for the Ceph, and VMware store for the ESX backends. One thing that many users of Glance are not aware of is that you could configure multiple stores, and you could specify, and you could have like a location strategy to direct the image to direct the way the image is stored onto a specific backend. This is like of really importance if you want certain kind of images to be stored on the file system and some of them to be going to an object store. More on it later. So as I said before, a store uploads the image data, and what it does is that it provides back to Glance API a specific location object. So the location is nothing but a URI which uniquely identifies the image data on the backend. For example, if it's a HTTP backend store, then it basically is like the HTTP URL of wherever the image is hosted. If it's a file system, then it's a location to the file where it's on the local file system. So it's basically just a regular URI with a different scheme for each of the different backend. So in order to retrieve the data, Glance provides this specific location object to the store, and it's the store's responsibility to parse this URI and fetch the image data from the backend. You get it? Yeah. So this is how you kind of create an image by passing a location. If you remember the state transition diagrams, you could, I know it's tough to remember that, but you could move an image from a queued state to an active state without actually uploading the image data. So what you could do is you could just pass in the location of the image data wherever it's hosted on one of the supported backend drivers, backend storage, and you could just pass the location, and Glance would just verify if the data is actually existing on that location, and then creates the image for you. So in this case, that there's like absolutely no data transfer involved. That is, you don't pass the bits to Glance API, and it never stores on the Glance backend. But it's but somebody has to do the heavy lifting, right? Somebody has to store the data. So it's the users who is providing the URL. They have done the due diligence and uploaded the data to their specific backend or their favorite backend and provided the location back to Glance. So this is another mechanism. This is very much helpful when you when you are like recreating Glance service on a different site. You could use the locations attribute, and then you could quickly create a bunch of Glance images that already existed. Okay, so far we had seen a lot of features for the end users and admins of Glance, but there is the next couple of things that we'll be talking about are like the operational features in Glance. For example, if I'm an operator, I would want some additional tasks to be done to a specific image when it's being uploaded. For example, say my cloud has a bunch of VMware hypervisors, and the users of my cloud have a bunch of QCOW images. So these QCOW images are not natively supported by the VMware hypervisors. So as an operator, what I need to do is I need to ask my users to convert all the QCOW images into VMware specific format, which is VMDK. This could be a laborious process for the users, and they may not even do it appropriately. So we have this concept of pluggable workflows to Glance. Out of box, we support introspection and conversion of disk images. So when a user uploads, say, a QCOW disk, the operator specified pluggable workflows will kick in and will convert the specific QCOW image to a VMDK and then upload to the backend. So this kind of makes the whole OpenStack thing very transparent, that you could provide any sort of images to your cloud, and the backend will take care of converting it to whatever format is appropriate for your specific cloud. So the users have no idea about what kind of hypervisors are running behind, as long as the conversion logic and other utilities that you use to convert the disk work properly. One another use case is if you're a part of a security company, you might want to scan the disk for some specific threads. You could attach a pluggable workflow to your external system, which does all these validations of a disk image and then appropriately specifies if it's a good disk or a bad disk. And this whole thing happens asynchronously, in the sense you basically post a task to the Glance API, and the task will go on and on, how much ever time it takes to do the conversions or the security checks. And the user could poll on the task ID, and then if the task succeeds, you basically get an image created, or if the task fails, you'll get an error message saying that the image was not being able to be created. So it's kind of a flexible, customizable way of creating images, but that's also its problem. So it's kind of started out like a new endpoint for Glance. In the next version of Glance, we in the next release, we are planning to make it seamlessly part of the regular image upload process, so that you don't have to worry about talking to a separate endpoint in order to create your images. You could be speaking to the regular Glance V2 API, and all these things will happen magically behind the scenes. And there will be integrations, on Horizon to Horizon dashboard to view the status of the task and other things. That'll be super cool. So I already said that this section is about the operational features of Glance. One of the most used utility to bootstrap Glance is Glance Manage. It is used to set up the Glance database, to run the migrate scripts, but it also has some of the other things that people are not aware of. You could use the Glance Manage utility to load or export or unload the metadata JSON files, metadef JSON files. I spoke about metadefs a while back. So you could upload those JSON files through this utility. And as your database grows larger and larger, and there's tons of records on the database, you could purge all those Glance image records that are deleted and over a specific period of time using this utility. It's kind of a handy tool. And then you have, I spoke a little bit about using locations as a way of seeding a new Glance service with images from an old site. There's a tool specifically written for this called Glance Replicator, which could be used to seed a new Glance service from a specific site that you have. It also provides some utilities to diff the contents between two different Glance services, or dump the contents from a server to a disk and vice versa. It's a cool thing because this way you can preserve the UUID and image metadata across different data centers that you have, and so that all your heat templates and other things which have the image UUID embedded into the templates could keep using the same, and there's no need to rewrite those heat templates, etc. So I think that's it about the set of features that I wanted to talk about. There are like few other things that are coming up in Mitaka, and if I get a chance to talk about it in the next session, whenever this bug smashes, I'll be happy to update these slides. And thanks to Brian, a lot of the content were from his slides, and to the developer docs. It's really resourceful. All the contents that I have can also be viewed over there. And thank you. I'll just stop the sharing and put my video on for any questions.
Yes, thank you, Sabri. That was a really good talk on Glance. I think people will definitely get a better perspective around what this project is trying to do.
Yeah, thank you. And I would encourage everyone to talk to me in case they have any questions further on this. I know it was like too much of content to cover in like 40 minutes, so I had to rush through a lot of things, but I'll be happy. I just want to put out the content that we have for all the features that we have for Glance.
Makes sense.
Yeah.
Any questions? Sorry? No. I would ask you a question, but then I don't know.
Whatever you're asking, I know you pretty much know the answer.
We'll be better chatting on IRC, right?
So once he said that sharing of image was stopped, and like he said on the Facebook post, you couldn't do it again. And in the video version, you need the permission. And what was the reason behind it? Was there any technical problem?
So he's asking, what are the
reason for
restrictions for image sharing, and what are the reasons you couldn't do?
So once it came to the V2 version, like you had to take the permission from the.
Is the question about why you couldn't allow tenants to further share the image in V2?
Yeah. Yes.
Okay, I don't know the historical reasons, but I think it's kind of I'm not too sure about why it was done, but I think it's a good thing to do. What do you think, Nikhil?
I was like confused about it. Look, initially you allowed people to share them, but again you need permissions to do it. Is there any technical logic or any something related to the overall functioning of the system?
I have no historical context on that topic. Sorry.
I wish there was a listener on this specific broadcast called Brian, who we could pick his brain for all the historical reasons.
Yeah, absolutely.
Yeah, but I think one of the things would be like the security implications of allowing to share further and further. For example, if I have an image that I want to share only with my department and it goes around with other departments, it'll be tough to for example, if I change something today and all the people in my department are aware of the things that goes in it, but if, for example, an image is like obsolete, it doesn't have a security package or something, if you keep on sharing this, it just becomes broader and broader, and it's tough to track who's using the image.
Yeah, and I think we wanted to do community images as well. So
yeah,
that was the alternative approach. Yeah, I'm not 100% sure on what exactly the reasons were on obstructing certain things and allowing certain others, but definitely makes sense on trying to be composable in terms of a single operation, and then the location of trust being minimal.
Yeah.
Thank you.
Yeah, because that's it.
the same reason your Facebook post, you don't want anybody else, like you don't want everybody to share your Facebook post over and over again.
Yeah, I think like LinkedIn has that restrictions on you can just share it within your connections and whether it's public or not. So
Yes.
you define like sort of a boundary,
Right.
sort of a lake boundary. Lake dries up and then it tries to fill it up, and you say, "Oh, this is the dam, and these are the big walls. You cannot."
Yeah.
Again, helpful because just consolidating it to one specific area. If anything goes wrong, then
Right.
that kind of people,
Yeah.
included can be informed.
So your trust zone is well defined.
Right. Because once people say, as you said, once you start sharing, you don't know where it has gone after
Right.
that, what damage people are getting.
And also there were users who complained about, like, for example, the V1, you could just share with anybody and it shows up on their image list. So that's why maybe that's the reason in V2 they made it like you have to like accept or reject the image.
Yeah.
I think Facebook and LinkedIn both, like you can like pay to like access people that aren't in your network.
Yeah, like in Greenland itself, like
Yeah.
you can just send an email, how do you say it? Just an acceptance. You just go ahead and talk to them. Like you just allow you have to pay for the premium service. Yeah, that's what they do. But again, it's restricted.
Yeah.
Just 2 emails to force you to talk to them.
Or even if like you run a meetup group, like you don't really have access to the people's email addresses, or like you need like a separate mechanism.
Right.
They want to keep you separate, right? Like that's their.
Your identity is like defined only to that meetup.
Right, yeah.
And what sort of description you give, that is what they know about you.
Right.
Yes. This is what I do. That's it.
Yeah, so I mean, I think like people followed you well in terms of sharing and how it applies to broad concept and how we are adopted into Glance.
Yeah, I encourage users to like join the community and then probably enhance this feature. I mean, it'll be really good for the team.
Thank you.
I should probably follow up with you in terms of what exactly the restrictions we're talking about, but because the question wasn't 100% clear to me, I was just repeating 2%. What I was about to say is, great follow up on what the image upload and tasks look like, and I think we may, once people, and I'm hoping that even operators see this, we would get some feedback in terms of what works for people and what doesn't work for people and how they want to use it. That would be quite useful to have it out there.
Yeah, that's my intention too.
Excellent.
So
yeah, I guess that's from us, unless you have something. Oh, I mean, that is the end of questions from our side.
Okay. Yeah, it was like I really wish I could make it there, but it's nice to meet you all virtually, and thanks for your time.
Thank you.
Yeah. Bye.